Hello, welcome to the Sunday Dojo Show. My name is Przemysław Rzepecki and I'm recording this in Stockholm, Sweden. Today we are going to look at the LCD coding dojo. Our goal is to change a string of numbers, digits, to a digits with this big multi-line representation like the old-style LCD displays that you could see in the, like, say, stock market exchange or railway station. So we start by writing a very simple test case. Simple. We'll see about it. We just take the one character. So let's copy the 0. And there should be the new line breaks also. So this should be output of our LCD of the single letter string from 0. So let's put the class for our object, and we of course need to declare that object in the test case, and it would be good to take this string representation for the font as a constructor argument. So let's quickly adjust the constructor in the class. And the other operation of our class will be to do the conversion. So for that we will use the call operator, and the call operator will also return the string and take the string as the input. In this exercise is really almost everything about the strings. It's a very good exercise to be familiar with the C++ string manipulation. Here we got the compilation problem, but the syntax looks correct. That should really compile. Haven't saved the file. Yeah. Now it's compiling fine, although of course the returned string is not the one that we expected. So let's try to parse this font string and split it to a single digit strings. So right now we have 4 lines in our font string, and let's iterate through them all. And whenever we will get a space in all of the lines, so if line 1 some offset is equal to a space, and the same goes for line 2, 3 and 4. Then we know we should cut strings and use that as a representation for the next digit. So now we have the if statement. Now we need to implement this cut. So we will store the result in a number vector, and now we need to construct this string from, let's say, previous offset up to the current offset, and that should be string, so standard string, plus new line, and that will be for the first line, so we need to repeat it for the second, third and fourth line. Okay, once we have parsed that one of the digits, we need to move the previous offset mark to the current position. Now only we need to, before we do this iteration, we need to split this initial font string into these 4 lines. For that we first change the font to input stream, and then we could use the standard library function called getLine. Just put the 4 empty strings, and now we use the getLine function, pass the string stream, and that will read up to the new line character and put that into our line strings. That looks quite okay. Just need to declare the vector of our digits in this LCD display. Just use the private member. And now to test it, we just return this element in the vector. So we just need to convert the first character of the given text to a digit value. And of course we need to correct all the compilation errors that I made. So first of all, to declare the offset, that should be the difference from the current iterator position and the beginning of the string. We need to also declare the previous offset, that should start from the 0. Okay. There are many more errors. Here we of course need to compare, so the double equal marks. And last compilation error is well, the previous offset should be equal to offset. And now it's compiling, although still failing. Seems that we are missing a space after our string. It's maybe difficult to read the output from the G-test in this example of multi-line strings, but you can see here we expect to be a space, and in our implementation we are stopping at this space, so we just cut our string 1 character more, and now the test is passing fine. So that was the simple case of a single character. Now let's try to put multiple characters together. So we'll have our LCD object, And let's check that the output of, well, let's say all the digits that we have will be correct. So let's use this complete string, and here we write LCD from 0, 1, 2, 3 up to 9. And also would be good to mix some digits in this string, not to, well, have exactly the same string as our font input. So let's just cut this 878 and put them in by the end, and do the same in this string of small digits. So it's correct. Right now our implementation just returned the first digit of the string. So let's get back to this call operator, and we should iterate over all the characters in the input text. And now somehow we need to concatenate those multi-line well, string representation of the digits that we already have in the number vector. So first of all we can just declare, and let's we can do the same splitting of particular lines now in this digit representation. So right now we will split our number, so so the string representing one particular digit, into separate lines. And then we could append those lines to our well, lines of the result. So we just declare 4 empty lines of the results. Let's call them result 1, 2, 3, 4. We split the string representation of one digit into 4 lines, the line 1, 2, 3, 4, and now we just append those lines to the result lines. And finally we need to return from our function well, all the lines together. So let's add them together and put the new line characters in between. That looks I think that looks okay. Although we're failing, and it's not so easy to see exactly why. However, it seems that our actual string is the replication of the 0 number. We are we are iterating, but all the time we are passing the text from 0. We should of course use the iterator value here. We are still failing. But now at least our string vary a bit. And well, the new line breaks are not matching from the actual to expected string. Seems that we are adding a bit too much spaces. And those strings are correct. And yes, we need to move the previous offset to of +1 as we cut it that way. Yes, now the test cases are passing. So we can now write a number on the LCD display. To see how actually it looks, we can just print it, not only use it in the test case. So for that one I will flash it to the output, and let's use some long string of digits. And now you can see all the digits printed on the my screen. So we just made the 2 test cases, and the implementation is quite long. We have quite many duplication in the code, and towards we are dealing only with 4 lines. So we have something to fix in the next show. See you then. Bye.